Students, moving to the configuration of the molecule. Configuration means the alignment of atoms or group of atoms in a molecule in space or three-dimensional space is referred as configuration of the molecule. So, we have selected one particular molecule. In that particular molecule, there are different atoms or groups. This arrangement of different atoms or groups in a given molecule in space is referred as configuration of the molecule. In that configuration, there are two types. One is relative configuration and the other one is absolute configuration. So let us look into these two configurations. Relative configuration. As the name itself indicates, in relative configuration, at the time of deciding the configuration of a molecule, the given molecule is related to another molecule, that the molecule with which we are going to relate the given molecule which is under examination to decide its configuration, that molecule, relating molecule is known as standard reference. I mean to say, at the time of deciding the relative configuration, the relative configuration is always decided by taking a molecule as a reference which is taken as a standard. One such standard reference molecule is glyceraldehyde. So this glyceraldehyde is taken as a standard reference molecule, and by comparing other molecules with glyceraldehyde as a standard reference molecule, we are going to decide the relative configuration of the given molecule which is under examination. In case of glyceraldehyde, which is having 3 carbon atoms, the one central carbon atom is the chiral carbon atom. An isomer which is having OH group towards right in the glyceraldehyde is taken as D. It is capital D. Please don't get confused between capital D and small d. Small d represents the optical activity, that is dextro, whereas this D, capital D, represents the D configuration of the molecule, which indicates the OH group is towards right on the chiral carbon atom, whereas another isomer which is having the OH group towards left is called L isomer. Again the same, capital L is indicating the configuration, not the optical activity. Optical activity is always indicated by small d and small l, whereas configuration, relative configuration is always indicated by capital D and capital L. OH group is towards right side on symmetric carbon atom and chiral carbon atom is a D isomer. OH group is present towards the left on the chiral carbon atom is considered as a L isomer. Therefore, glyceraldehyde is the reference molecule which is taken as a standard. By comparing with this molecule, we are going to decide the relative configuration of any other molecule which is under examination. Coming to the absolute configuration. The absolute configuration is again is having 2 different configurations, R and S configuration. In this case, we are going to decide the configuration of the molecule by taking the molecule itself by following a set of conditions. Here we are not going to refer or we are not going to compare the molecule with any other standard molecule. So, in absolute configuration, we are going to decide the molecule as R and S. R stands for rectus and N stands for sinister. Rectus and sinister. To decide whether the molecule is whether R or S, we are going to follow the following set of conditions. First, we need to assign the priority for 4 different atoms which are bonded to chiral carbon atom, such as 1, 2, 3, 4. The first priority should be given to an atom which is having highest atomic number. I mean to say, the priority should be assigned to the atoms which are bonded to chiral carbon atom in the decreasing order of their atomic number. An atom which is having highest atomic number gets the first priority. Then come, if the atoms of the same elements which are isotopes, if 2 different isotopes of the same elements are bonded to the chiral carbon atom, then an isotope with greater mass gets the first priority. Coming to, if the atoms which are bonded, if two atoms which are bonded to chiral carbon atoms are same, then we used to consider the next atom to assign the priority. I hope this point is very clear. If two atoms which are bonded to chiral carbon atoms are identical, then the atom next to first atom is taken into consideration to assign the priority. And the fourth point, if any atom is bonded with a double bond, that should be considered as equivalent to two atoms. And if any atom which is bonded with the triple bonds, that would be considered equivalent to three atoms. So by following these all the set of conditions, we are going to assign the priority to the atoms which are bonded to the chiral carbon atom, such as 1, 2, 3 and 4. Now let me consider glyceraldehyde itself as an example. Now the first priority goes to, remember, oxygen. The second priority goes to the aldehyde group, because the oxygen atom, since it is bonded to carbon with a double bond, that oxygen is considered as two oxygen atoms. Therefore, second priority goes to aldehyde, third priority goes to your CH2OH group, and the last priority comes to your hydrogen. And after assigning the priority as 1, 2, 3 and 4, which are bonded to chiral carbon atom, the molecule must be viewed in such a way that the group, an atom or a group with the last priority 4 should be away from the observer. Away from the observer. I mean to say something like this. You please take the molecule like this, and by taking the molecule like this, remember, you are going to take the molecule like this, and this is away from the observer, and this is OH, and this one is CH1, and this one is CH2OH. Now we have priorities as follows. This is OH, oxygen is number 1, the aldehyde is number 2, and CH2OH is number 3, and the fourth is away from the observer. Moving from 1 to 2 and 2 to 3. So at the time of moving from first priority to second priority and second priority to third priority, when we move in the clockwise direction, then that isomer is called R isomer. And if you take the mirror image of the same molecule, that becomes the S isomer, because if you take the mirror image and this is CH2OH, and that becomes CH2OH, and this becomes OH, then this is 1, 2, 3. So this becomes 3, and in that case you are moving from 1 to 2, 2 to 3. When you are moving from 1 to 2 and 2 to 3, your eyesight is moving in the anti-clockwise direction, then it is called as S isomer. So moving from 1 to 2, 2 to 3, when you are moving in the clockwise direction, that is R isomer. When you are moving from 1 to 2, 2 to 3, when you are moving in the anti-clockwise direction, that becomes S isomer. Then, when you rotate the molecule, remember, in Fisher formula, to decide the R and S, first rotate the molecule through 180 degree, then H and OH, they are get interchanged. And in the second rotation, you have to rotate in such a way that a group with the last 4 priority should be at the bottom. Please observe very carefully. There must be 2 rotations. The first rotation is to interchange the atoms or groups which are present in the horizontal position. So the OH which was in the left, it has get shifted to right. In the second rotation, you should take care that the atom or a group with the last priority 4 should be at the bottom. ಯಾವುದಕ್ಕೆ ಲಾಸ್ಟ್ priority 4 ಕೊಟ್ಟಿರ್ತೀರೋ ಅದು ಬಾಟಮ್ಗೆ ಬರೋ ತರ ನೀವು rotate ಮಾಡಬೇಕು. ಈಗ ನೋಡಿ, this 1 to 2, 2 to 3, you are moving in anti-clockwise direction, then it is an S isomer. This is how we are going to decide R and S configuration in Fisher formula. Okay. So there is a small correction. So this is your glyceraldehyde. So this is your glyceraldehyde. So this your in the first rotation there is an interchange of H and OH. In the second rotation, a group with the last priority 4 should come to the bottom. Now this becomes 1, 1 to 2, 2 to 3. You are moving in the anti-clockwise direction. Then it is an S isomer.